started in Domain 1, just to get it kicked off right. We're going to talk about IT concepts and terminology throughout all of Domain 1. So, what is going to be in there? Well, first we're going to look at comparing and contrasting our notational systems out there, how we view and how systems view this data. Then we're going to look at the fundamental data types, look at some characteristics in there. Then in the third subdomain there, we're going to illustrate the basics of computing and processing, and how data comes into the computer, we do something with it, and then we have to do something with that data. Then we're going to look at the value of data and information, and I'll probably get on some tangents about that. I'm going to try to keep it in an IT fundamentals realm there. We'll look at some common units of measure, right, which I'm looking forward to because I see this on social media incorrectly all the time. And now you can be one of those grammar Nazis like me that will correct folks when they put the wrong information on, say, Facebook or Twitter or Instagram or whatever. And that may make a little more sense when we get to there. And then lastly, we're going to explain the troubleshooting methodology, which there's not a lot of explaining there. By the way, what I normally do for my training videos is I will take the objectives, which CompTIA does a fantastic job at doing. They lay out all the objectives of everything you need, they think you need to know for the exam. That's what I teach to. So what they do in this troubleshooting methodology is they've put the methodology right in the objectives. So there's not a lot to explain per se, but we're going to go through what they have on the objectives, and yeah, I'll probably add in some tidbits, but they're going to be, the steps are already there. So with all that being said, let's jump into Domain 1.1, which is kind of a short one, but it's important nevertheless, where we're going to compare and contrast notational systems. So the first one I want to talk about is binary. Right? If you've never been in a computer class before, or I don't know, sometimes they'll throw this around in TV shows and on movies and whatnot, but binary numbering systems, that's what computers are built off of, as far as we know now. And what I mean is, 30, 40, 50 years, 100 years down the road, they may find something even smaller as far as data that we can manipulate. Right now, this is as small as it gets. It's either one or the other. That's what binary is. It's called base 2 because you have two options. It can be either on or off, and before everybody starts yelling at me, yeah, I know it's probably more of a high and a low. We call them ones and zeros, all right? Where the one is on, zero is off. It's not exactly true, all right? So if you go out there and you start talking to somebody that's been in IT and you're like, oh, well, binary is on or off. They may try to correct you a little bit because it's really more of a high and a low, but it's so low it's almost off. So I'm not going to split hairs. I can't really do that anyway, as you can tell. But anyway, ones and zeros, binary. And I put some examples out there like the 0, 0, 0, 1, 1, 1, 1, and 1, 0, 0, 1, 0. It doesn't matter, all right? They can all ones and zeros. That's the only numbers you're going to have. Right? You shouldn't see any 2s or 3s. Definitely not going to see any letters. All right? But this is how computers make sense of what's going on in the background. Now, what we can see as humans on how the computers are manipulating this data or how they're interpreting the data from input to output and then giving it to us even, right? How we're understanding it as humans, they will use the hexadecimal. And we can actually see this, right? If we had multiple computers set up here, and I know this is not a security class, but if we had two computers sitting here and I had, some type of packet analyzer like a Wireshark sitting in between here, and we saw the data going across, right, through the air if we had the correct equipment, or through a switch or whatever, we could see that data. Now, when we see that data, we usually see that in hexadecimal. Right? And then we would interpret that, and we're going to get to that in the next few slides. But hexadecimal is base 16. And base 16 means it has 16 different characters, 0 through 9, and then A through F. And that's the part where a lot of people, especially if you're just getting started in IT, they'll look at this and they'll be like, oh, I got to back up. This reminds me a lot of algebra, right? When they start putting letters in your math, it seems a little confusing to some. Same thing here. right? We have addressing, there's hexadecimal addressing, and the data is interpreted the same way. But you will literally see some like 41, 42 hexadecimal values, and you have to be able to, not for this class, but later on down the road, right? We'll have to be able to look at that and say, oh, 41, well, that's a capital A. How'd you know that? I'm going to show you that here in just a second. Lastly, we have decimal. This is something that you should be very familiar with because this is what we use as humans all the time, right? I ask you how many miles it is to the store and you 3 miles down the road. You don't tell me it's 0.0000011, right? Like it would be in binary, right? You tell me decimal numbers. Our computer would be like, oh, it's 0.00000. I forgot how many zeros I said. 11, right? That's how they would look at it. We use base 10, 0 through 9, right? So if I say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever, you understand that as humans. And that's what we use all the time is the decimal system. Now, all three of these are important. Do you need to know how to, take all the binary and all the hexadecimal and all the decimal and all this? Maybe not. I don't think they're going to give you any hands-on for that, saying, okay, here's a hexadecimal number, tell me the decimal equivalent. I'm going to show you how to do that. We're going to attempt to do that. But I don't think they're going to ask you to do that on the exam, but I do want to show you how we can go from one notation system to the next and how it kind of makes sense. Because what we want to get to is this right here, our data representation, or ASCII, which is the American Standard Code for Information Interchange, meaning how do we pass this data back and forth, right? Well, I just told you it's binary for computers, and then we'll have the hexadecimal in computers, and then there's decimal numbers in there too, but that really doesn't pertain to a lot of numbers, characters, if you look at the ASCII table here, all right, I'll look at it with you. So if you look at this ASCII table, and again, this is a Google Images snapshot. I did not make this. I'm not responsible for this. But if you look, we have 3 different columns. I know there's 4 areas in there, but there's 3 columns in each one of those areas. A decimal column, hexadecimal, and a character. So if you look at the 3rd column over where it says decimal, hex, character, and the decimal starts with 64, 65, 66 in the blue or purple there. Well, the corresponding characters is like hexadecimal 41. Well, that's a capital A, like I said earlier. 42 is a capital B. 43 is a capital C. So that's how the computer will take that information, right? Again, if we were looking at it in some packet analyzer, we would see the hexadecimal, right? It would be down in the bottom, and we could interpret that, right? Because I can literally see the numbers and say, oh, 88, 42, 43, any of these numbers, 118. Right? Any of those hexadecimal numbers correspond to those characters. Now, do I have all this memorized? Absolutely not. Do I know where to find the information? Absolutely, I do. Do you need to memorize this table for IT fundamentals? No, you do not. I found it. I thought it was very interesting. Now you can pretend, you can read The Matrix, right? Next time you watch that movie and you see all those letters and stuff come down, right? I think that's what it's supposed to represent. It doesn't really represent anything. But that's the idea, right? That's the coding in the matrix. This is what they would be talking about, is this ASCII table, right? You would see the hexadecimal coming down, and as you see a corresponding value, you know that corresponds to a lowercase c or the space bar or something to that effect. And then lastly, we have Unicode. Unicode is out there. This is, and I pulled that definition, I think, straight from their website, computing industry standard for consistent encoding, consistent representation, and handling of text expressed in our writing systems. So take just a second, look at that slide. What do all those little pictures look like? That's right, they kind of look like emojis, don't they? And that's exactly where they get this from. Right, they encode this data representation, all that Unicode, right? All those pictures, all those emojis that we use everywhere nowadays, that's where this information comes from, right? That's why every so often you hear, oh, they added new emojis, right? That's not an Apple thing. That's not a Samsung thing. That's not a Google thing. That's the Unicode computing industry standards that set this up. They dictate who gets the emojis or these little pictures and not, right? Now, how Apple, Samsung, Google, Microsoft, all the companies interpret that information where they may make it look, like a yellow circle, or make it look a little different, that's fine. But the standard still comes from this, and they all follow this standard. That way we know, what is that, 1F988 looks like a shark, and that's going to be represented through everything based off of this standard. So that's how we use these encoding standards. We take that hexadecimal and binary, encode that, right, to ASCII so we can understand it, or we can encode it to Unicode so we can have our pictures or our emojis and all these graphics. Not full-blown graphics, I shouldn't have used that term. It's more of these simple emojis. Graphics was a total bad term. Don't think graphics when you think Unicode. So that's how that data is represented to us. All right, that's going to wrap up Domain 1.1, where we looked at comparing and contrasting the notational systems. I'll see you in Domain 1.2 here in just a few seconds.